Hello students, welcome to SmartKidz tutorials. In this video, we'll be moving to the second part of the chapter is matter around us pure. And in the previous chapter, in the previous video, we covered what are solutions, what are suspensions, what are colloids. We've seen examples of solution wherein we saw how salt dissolves in water and we can't see traces of salt at all in water. Then we have suspensions where suspended particles are present throughout the mixture. And then we saw what are colloids, okay, as in the form of milk. So moving on from there, we also saw the Tyndall effect, which is very much visible for colloids and for suspension, but is not visible for solutions. And Tyndall effect is because of the ability of particles to scatter light. So bigger the particles, the more the ability of those particles to scatter light and the tendency to exhibit the phenomenon of Tyndall effect. Now we come to separation of components of mixtures. We have mixtures, but what if we want whatever makes the mixtures, as in the different substances that make the mixture, what if we want to separate them out? How do we separate them out? Now we'll have a look at that. Okay, and we have different types of mixtures. We can have liquids, we can have solids. Okay, so and we can even have gases. So when there are different types of mixtures and you want individual substances or what makes up those mixtures separated out individually for use, then how do we do that? What are the different ways in which we can separate out the components or what makes up individual substances of this mixtures? We'll have a look at them. So the method to be used for separating a mixture depends on the nature of its constituents. Okay, and we'll see what it means by nature of its constituents. The first thing, when we want to separate two solids that make up a mixture. The second case we'll look at when we want to separate a mixture of a solid and a liquid. And in the third instance, we'll look at how we can separate a mixture which is made up of two liquids. Okay, so one by one we'll cover these subtopics, beginning from with a mixture of two solids. So in this video, we will only be covering mixture of two solids and mixture of a solid and a liquid. And watch the next video, which will be coming after this, to learn how to separate mixtures containing two or more liquids. Coming to mixture of two solids. Whenever a mixture contains two solids, it can be separated by one of these following methods. One is by using a suitable solvent. Second, by using the process of sublimation. Okay, and third would be by using a magnet. We'll cover each of this in the following slides. Separation of mixtures by using a suitable solvent. Okay, now this method is based or centered around the solubility of those solvents. See, here we are looking at two solids that we want to separate out. Okay, the solids over here can be taken as solutes, which are dissolved in a solvent. So the ability of these solutes to dissolve in the solvent, that is what is exploited in this, or that is what is used in order to separate these two solids, a mixture of two solids. Okay, so before we come to the application, I would like to show you the figure over here. Okay, so let's say we want to separate out two solids over here, and that would be a mixture of sugar and sand. Okay, We know sugar dissolves in water, but does sand dissolve in water? No. If sand would have dissolved in water, we would have not had those lovely beaches that we have. Okay, the sand that is separate, the water is separate. Sand does not dissolve in water. So let's say if we mix sugar and sand together, and that mixture we dissolve it in water. Now, if we stir that mixture of sugar and sand along with in water, we can be sure that the sugar that is present between the sand will surely dissolve. After that, if we take that solution, okay, rather not solution, rather we mixture, and we pour it through a strainer, okay, into and collect whatever comes out through the strainer into a beaker or a glass cylinder, the of colorless liquid, okay, that will be actually the sugar solution will come out, or will you will be able to collect in the glass beaker. What will remain on the strainer will be your sand. It is the same as like how we do tea at home, okay, and sometimes some people have the habit of actually mixing the sugar in the vessel in which they are boiling the tea. Okay, and some have obviously the other habit wherein they pour the tea and then they mix sugar in the individual cups depending on whether how much of sugar they want. But sometimes when the tea is made for a large number of people, you can't do it individually. So what do? You take the sugar and you directly dissolve it into the boiling liquid, that is the tea. Now, when we have the tea, what we do, we pass the tea through a strainer so that we don't get tea powder in our or tea leaves in our glasses, in our cups. What we get is our tea which is sweet because sugar is dissolved in that tea. What remains in the strainer are your tea leaves or your tea powder. Okay, so in this case you know that the tea powder does not dissolve in the tea, which is the liquid, which is whether depending whether you have dissolved milk in that or whether it's just water. Tea powder does not dissolve the in your tea, but the sugar that you have put, okay, for your taste, that has dissolved. How do you know that it has dissolved? When you drink, it tastes sweet. That's how you know that the sugar that you mixed in that tea did dissolve within that. But the tea powder remains on the strainer, okay, or the tea leaves remain on the strainer. So this is how we mix, how we separate out a mixture containing two solids. Okay. A similar process can be used for separating out sugar and solvent by using alcohol as a solvent, because we know that sugar dissolves in alcohol, but salt does not dissolve in alcohol. The salt will just remain aside. Okay, and similarly, the other application is mixture of sulfur and sand can be separated by using carbon disulfide as a solvent. Separation by the process of sublimation. First, we need to know what is sublimation, and that we have actually covered in the previous chapter of matter. A sublimation, in the process of sublimation, the solid does not uh, get converted to liquid before getting converted into gas. Okay, like for example, we have ice, a cube of ice. Okay, if we leave it outside, okay, outside the freezer means at room temperature, the solid ice will melt into liquid water. And if you leave it like that for depending on the humidity conditions outside and depending on how hot or cold it is, over a period of time, the liquid water will also evaporate. That means the liquid water turns into gas, that is water vapor. Now, so the process is how? from solid to liquid to gas. But in case of sublimation, the middle part is skipped, as in it does not go into the liquid phase at all. From solid phase, it moves into the gaseous phase. So it's like saying the solid ice directly evaporates. That is what it means. Of course, ice doesn't undergo that process. But in this case, we have two examples that and we can see two of them on the screen over here. The top one is about when iodine is heated. So when iodine pellets, okay, small tablets, like if they are heated, then directly they turn into this purple fumes that you can see, violet or purple fume. You see over here, and down below that you can see out here, this is nothing but your solid carbon dioxide, which when exposed to air directly looks to evaporate. So this is how it would look like when solid carbon dioxide is actually exposed to air. Okay. And there are other applications also that exploit this process. For example, mixture of common salt and ammonium chloride, okay, can be separated by the process of sublimation. Okay, so sublimation is seen in case of, I told you about iodine, solid carbon dioxide. Then there are others like camphor, ammonium chloride is there in stated in this application over here. There are also naphthalene balls. So the naphthalene balls, you must have seen. Sometimes we put it in our bathrooms, in a wash basin. Those white tablets, okay, they smell nice. Now, they will, over a period of time, they will just disappear. They don't melt, okay, but it's for a reason that you're getting that aroma, you can say, or that smell, the pleasant smell that you get in your bathroom when those naphthalene balls are put in your bathroom. That's because the solid is getting converted to vapors of naphthalene, which you can smell. Yeah, and that's why it smells pleasant in the bathroom or in the toilet, in the laboratory, and so forth. Coming to the third part of separation of two solids, then in this case, the last part we look at separation by magnet. We'll see what we see the picture over here, and in this we see there is a bar magnet that is moved around, and this is a mixture containing iron filings. So the iron filings are attracted towards the bar magnet, and they will be pulled by the bar magnet, and whatever remains behind are the solids which are not attracted by the bar magnet. In this way we can separate out two mixtures, where one mixture is attracted towards a magnet, and this can be used for separating out iron filings and sulfur powder or carbon powder. In factories, scrap iron is separated from a heap of waste material by using electromagnet fitted to the crane. Then next we come to the second separation mixture. Cancel this part, cancel this part. Then next we come to the separation of a mixture of a solid and a liquid. Now in this, a solid and a liquid makes a mixture, and this have to be separated by one of the following processes. 1. By filtration. 2. By centrifugation. 3. By evaporation. 4th, by crystallization. 5th, by chromatography. And 6th, by distillation. And these are very, very important separation mixtures in our industries, okay, and very frequently used, all of them, and they have wide applications, all of these that you see on a commercial basis. highly used. Filtration, centrifugation, evaporation, crystallization, chromatography, distillation. We can carry out all of this on a very small scale in our labs, but we also use them on a large scale in our industries. We also use um, uh, a lot of them more like for example filtration, then we can use evaporation, we also can also use distillation in our homes as well. Okay, coming to filtration. What is filtration? You must have seen filtration a number of times at in your houses as well. Okay, and I just give you an example of a mixture of your um, tea, okay, containing your tea powder or tea leaves. Now, once you finish boiling, the tea is ready. You're ready to pour the tea. You want the tea. You don't want the tea powder or tea leaves while having your tea. So what do you do? Before you consume the tea, or you put the tea from your kettle or from your vessel the into your glass. So the tea powder remains behind on the strainer, and what you get is your tea. That is the simple process of filtration, and the similar processes even employed on a large scale in various industries. Filtration is used for separating insoluble substances from a liquid, substances which do not dissolve in a liquid. So this means that a heterogeneous mixture of a solid and liquid can be separated by the process of filtration. Applications: mixture of chalk and sand, water is separated by filtration, then tea leaves, as I mentioned to you, and there are many more applications. These are just two that are mentioned here. Coming to the next one, we have centrifugation. Okay, and in centrifugation, what we do is it is a method that is used for separating suspended particles of a substance from a liquid in which the mixture is rotated at a high speed in a centrifuge. By this, as a mixture rotated around rapidly, a force acts on the heavier suspended particles in it and brings them down to the bottom of the test tube. The clear liquid, being lighter, remains on top. See, this is what you would call a manual centrifuge machine. Nowadays, we have automated centrifuge machines. Okay, but in certain labs, you have such centrifuge equipment wherein what you do is the mixture containing the solid and liquid, and particularly the solid the having is which is heavier. Okay, when it is rotated around like this at high speeds, it settles down to the bottom, and what you get on top is a clear liquid. Okay, and this is how we can separate out a solid which is mixed in a liquid. Okay, and show you here, and when you can see here that the mixture has separated out, and this same procedure actually can be used for separation of blood components. When you draw your blood, and if you want to separate out the plasma and the part of the blood which gives you the red color, that means your erythrocytes or red blood cells, you can run it through the centrifugation machine, and what you can after that what you'll get is that the heavier red blood cells will settle down to the bottom, and on top you'll have the plasma, which is a clear colorless fluid. Okay, and centrifugation is used in a number of processes. It's not just the applications that are mentioned over here, but there are a number of applications of centrifugation highly used in labs for separation of various suspended particles, okay, from a liquid. As we say, you can also use it to separate cream from milk. So it's even used in the dairy industry. Coming to evaporation, uh, we usually use evaporation in order to separate salt from salt water. Okay, and used in salt pans for that process. And this process is widely used. Nowadays, you also have refineries, salt refineries, which refine give you refined salt. But on a domestic scale, even till today, you have domestic or local salt makers who actually use the salt pans, and they use the process of evaporation. So they depend directly on sunlight, okay, and heat to evaporate the water so that salt is left behind in the salt pans, and then that is sold in the market or directly to consumers. Okay, not your packet salt, which you get in your supermarket and in various kirana stores. Okay, now evaporation used to separate a solid substance that it can be that is dissolved in water or any other liquid. Now, this process is based on the fact that liquid vaporizes easily. Now, this one depends directly on the fact here the solid is dissolved in water. Okay, but dissolved in water or any matter, depending on the type of solid that you are looking to separate from the mixture. Uh, it depends on vaporization process. That is, the liquid is vaporized, leaving behind the solid as a residue. Here you can see this diagram over here, where you see there's a mixture of salt and water, and there's an evaporating dish, and since there's no external heat, I mean there's no heat, sunlight, so there's a heat Bunsen burner that is supplying heat from beneath, and in that case what is happening is the water is getting evaporated as the water boils, and that leaves behind the salt which was present within the salt water or in that mixture. Applications: common salt dissolved in water can be separated by evaporation. We can also separate colored components of ink by the process of evaporation. So evaporation is used for recovering dissolved solid substances from liquid mixture, but the liquid itself cannot be recovered by this method. So if you're looking to recover the liquid, then you can't recover, because see, in this also figure it shows that the water gets evaporated. Okay, so here the water was in liquid form. Evaporation is mainly based on liquid getting changed into or converted into water vapor, or if it is water, if it is any other liquid, it will get converted into gas, and the liquid is lost, at least to us. Okay, we can't recover the liquid. We can recover the solid which was dissolved in that liquid. So it's not a good process if you need the liquid also to be separated out from the mixture for use. Coming to crystallization, crystallization is extremely used in nowadays to obtain high grade pure crystals in various industries. It's an expensive process, but you can get really good quality crystals of a particular substance that would have wide applications in various industries. Okay, the figure that you can see over here is the one that is mentioned in your textbook. It's about copper sulfate solution. Okay, and that copper sulfate solution is in this vessel over here. Okay, and this vessel is placed on another cylindrical cylinder, and that cylinder is in direct contact with this burner over here. And in this, so you where this burner will heat up this particular cylinder, and as the cylinder heats up, the vapors that will rise will heat up the vessel over here, and in turn it will heat up the copper sulfate solution present within the sulfur. So in other words, the copper sulfate solution is not in direct contact with this Bunsen burner. So we are not looking to boil the copper sulfate solution, but we are looking to heat the copper sulfate solution. And in doing so, we are trying to obtain pure crystals, because if we directly keep this copper sulfate solution, this china dish, onto this wire gauze, which we will be in direct contact with this burner, and in that case we will lose those crystals. We will not get those crystals, but we need those crystals, and at the same time we can't get those crystals without application of heat. So this is the best way to do it. That is, you have your cylindrical vessel or your some jar, and you place boil water in that. You boil the water, and the fumes or the heat that is generated, the steam, will go on to heat this china dish. In other words, heat the copper sulfate solution and leave behind only sufficient heat is applied, limited heat is applied, so that we get our copper sulfate crystals. So what happens in crystallization? Process of cooling a hot concentrated solution of a substance to obtain crystals, that is called crystallization. Okay, this method is used for obtaining pure solid substance from impure sample. When you say impure sample, whatever is not required by us, that becomes the impurity as part of that mixture. Okay, that is what it means by an impure sample. So see over here, it doesn't refer to boiling. It says the process of cooling a hot concentrated solution. So it just has to be hot enough so that we get our crystals. And when do we get our crystals? When this copper sulfate solution, which we have heated now, cools down. And as they cool down, uh, we get these crystals forming in the china dish, in this vessel. Application, this is one of the application, that is to impure copper sulfate is purified by the method of crystallization to obtain pure copper sulfate crystals. Okay, and an activity is mentioned in the textbook, and this is the activity that it refers to, where we take 10 grams of copper sulfate and we dissolve it in minimum amount of water, that is over here, to make a copper sulfate solution. So this is a copper sulfate solution obtained by mixing copper sulfate powder into the water. Now, next we need to filter this solution to remove any impurities. So once we dissolve, whatever impurities which are present or additional substances that are present can be removed just by the simple process of filtration, which we where in filtration we use filter paper to filter out the impurities. Next, we need to heat this copper sulfate solution gently on a water bath. This one is a water known as a water bath. Okay, and to evaporate water and obtain a saturated solution. So once this liquid also heats up, it begins to evaporate, and what is left behind is a very concentrated solution of copper sulfate. Then we need to stop the heating. We can't endlessly heat that, and once the heating is over, we take this vessel and we either keep it aside, or what we do is we remove the Bunsen burner. As you can see over here, the Bunsen burner has been removed, and slowly the liquid or the solution in this china dish is allowed to cool. And as the saturated solution of copper sulfate cools down, it begins to show copper sulfate crystals in the china dish. That's the process of crystallization. The crystals of pure copper sulfate solution are formed, and impurities remain behind in the solution. So once again, you need to carry out filtration to get rid of those impurities. Okay. The common salt is also purified by the process of crystallization. When we were talking about our evaporation, and I spoke about local vendors who make salt in the salt pan, and they provide, they just purely depend on evaporation process. Whereas some big names, like for example, you have your Tata salt and some other salts that are marketed in the supermarket in branded salt. That is what I mean. Okay, they are white crystals. They're white crystals because they undergo the process of crystallization. A lot of purification and refining process goes into bringing to you the white salt crystals. So the difference between crystallization and evaporation. If you take some solid like sugar decompose or get charred on heating to dryness during evaporation, there is no such problem in case of crystallization. Then the soluble impurities do not get removed in the process of evaporation, but such impurities get removed in crystallization. This is exactly what we see when we get salt from local vendors who just dry it in their fields. Whereas the salt that is available, branded salt that is available, you won't have find any impurities, and it is very smooth, and it's like a grain of sand, just will slip through your fingers. Whereas the salt that you get from your local vendors will have a lot of dirt. You'll have to also do a lot of drying, okay, before you can think about using them. Coming to chromatography, another method that is used for separation of solids that are dissolved in liquids. Okay, and on your right here you can see the figure which shows the process of chromatography. This is actually a paper chromatography. There are different types of chromatographic methods. You have gas chromatography, then high pressure liquid chromatography, and paper chromatography is quite well known and widely used, especially in labs, because it's very easy to exhibit, to show, and to carry out the experimentation as compared to all other chromatographic methods. So we'll have a look at what is chromatography. So chromatography is a technique of separating two or more dissolved solvents which are present in very small quantities. The separation is based on the fact that two or more substances are soluble in the same solvent, but their solubilities may be different. Okay, the most common type of chromatography is paper chromatography. So if you have two or more solids that are dissolved in liquid, depending on how soluble they are, okay, that will decide on how quickly they can be separated from the mixture. And now in this method, probably there are, you can see three different types of colors. They can be different types of organic solvents as well, which are mixed over here. And you have a solvent over here which moves up this paper actually. And as it moves up this paper, it also takes along with it the other solid that moves with the liquid over here. You see, so a simple experiment can also do, wherein we can use a paper at home, and we can put mark a line at the bottom around, and we put probably a marker or a felt pen we can use, or a highlighter on a particular point, and dip that into a suitable solvent, and alcohol would be the best. And as the alcohol rises up, okay, in through this paper, it will also take along with it the highlighter color, and how far it moves depends on a number of factors, including how far this liquid can move up, and how much of the solute can move or separate out from the particular mixture. So example is black ink is a mixture of several colored substance or dyes which can be separated by paper chromatography. Applications: chromatography is used to separate the solution of colored substances. Apart from just being separation of colored substances, it has a number of applications. Okay, applications that are widely used in various industries. It is used in forensic science to detect and identify the trace amount of substances like poison in the content of the bladder, or stomach. It is also used to separate small amounts of products of chemical reactions. So here is the activity that I was actually mentioning. And you see there's a strip of paper taken, a line is drawn, okay, suitable from the bottom. And this line actually should be above the liquid level, okay, should not be dipped below this line. And on this line, there's a line drawn by pencil. And on this line, you spot it by an ink, or just place a pen, a felt pen, or a highlighter. Mark a spot on that, and on that spot itself, you use your highlighter on that. Okay, and this strip of paper is placed in a jar. This jar contains water. Okay, and the paper is dipped into the water in such a way that it is does not touch this line. That means the level should be, I mean, it should be dipped only to that level which wherein the line is above the water. Okay, so the spot should not be dipped in water, and we should keep this in a jar. And over a period of time, and this may take like hours, okay, for the process to actually complete. And as the water rises through this filter paper, the point, the highlighter that you marked over there, which could be any color, could be green, yellow, orange, red, it will also slowly rise as the water rises through this strip. Okay, so water gradually rises up the filter paper strip by something called as capillary action. As water moves up the paper strip, it takes along the dyes present in the ink. The dye, which is more soluble in water, dissolves first, rises fast, and produces a color spot on the paper at highest position. That is when it moves up. The less soluble dyes rise slower and form colored spot at lower position. So they will be lower over here. When the water reaches near the top of the strip is removed from the jar and dried. The paper with its separate color spot is called as a chromatogram. So you take this once the water has risen right on top, you take the paper, dry it, okay, and after drying you can then analyze how far the colored dye has moved. This strip of paper now with this um, migrated dye is known as a chromatogram. And last we come to the distillation process, the final one in case of separation of mixture containing solids and liquids. So distillation depends on boiling points, okay, of the substances within the liquid. Here you have a look. This is a glass, okay, jar, and a Bunsen burner is placed, and the water is boiling, and vapors are rising. So as the vapors rise, they move through this pipe, and this pipe is fitted to a cooling water cylinder over here. And as the vapors pass through this glass cylinder, the vapors cool down and they condense. So as it condenses, the water drips, or the water gets collected in this conical flask over here. Okay. So distillation is the process of heating a liquid to form vapor and then cooling the vapor to get back the liquid. In order to recover both solid as well as liquid from the mixture of solid and liquid, the process of distillation has to be used. Liquid obtained by condensing the vapor is called as the distillate. So this is the process. So you heat the liquid containing the mixture. The liquid upon heating will form vapors. The vapor will then cool as it moves down this tube because of this cooling water present over here. And as the vapor cools, that is condensation takes place, the vapors turn into liquid, which is collected drop by drop in this conical flask. Okay, and this liquid that is now obtained is referred to as the distillate. So this liquid consists of a homogeneous mixture of solid as well as liquid. Okay, it is heated in what we call as a distillation flask, and the liquid being volatile, that means its ability to get converted into vapors, gets vaporized. The vapor of a liquid is passed through what we call as the condenser. So this part is referred to as a condenser. That means it facilitates condensation, where it gets the vapors get cooled and condenses to form pure liquid. The pure liquid is collected in a separate vessel here. Okay, and the solid being non-volatile, that means it does not get evaporated, it will remain behind in this distillation flask. Application: mixture of common salt and water can be separated by the process of distillation. Okay, so with this we end our video over here. Uh, so in this video we did cover two processes of separation of mixtures, one involving liquid mixed with liquid, solid with solid, and solid with liquid. In the third part, that is in the next video, we will be going through or learning how to separate mixtures containing liquids and liquids. Okay, so if you found this video helpful, please share it with your friends and classmates. Subscribe to the channel if you haven't done so, and not forget to like the video if you have liked watching this video. Thank you for watching.